Okay.
Okay.
Okay, welcome everybody to this rearranged webinar, but nonetheless eagerly anticipated. We do have literally an international audience this afternoon. So can I say good morning, good afternoon, and good evening to everybody at the same time. Depending on which hemisphere you're in, I hope you've had a good summer. We're about to experience autumn and winter here in the UK, but for some of us, it's going to be spring and summer. We are recording the presentation and it will be made available later on through our normal social media outlets. We will have a question and answers at the end, and I'm anticipating our very special guest speaker will talk for about 45 minutes to an hour. If you wish to ask a question, you can either raise your hand visually, like myself, or use the chatter box and write your question, and I'll try and get to your written answer. Written question, sorry, as best I can. One thing is to make sure that our speaker has proper connections to everybody is to turn your sound off and video, but we'll probably do that through John's chairmanship of the electronics. Could I remind members that we have a special event coming up on it's not an SHA event, but it's to do with the culmination of the William Herschel celebrations of his life, to be held on October the 1st, and is a conference, a centerpiece of the Herschel Society's celebration of William Herschel's achievements during this 20th anniversary of his death in 1822. We've sent out all the information to do with that event. You can either go in person or you can actually link up online to take part. And can I also remind you of our own event, which takes place on October the 22nd. It's going to be our annual autumn conference and AGM. And there's a great lineup of speakers. And it is happy news to announce that Dr. Alan Chapman will be available and will be our main speaker on that date. Of course, circumstances allowing for the event to take place, but I'm hoping that it will go ahead. Okay, just wishing to introduce now our speaker during this very special webinar. In fact, we have two people I need to introduce. First of all, Wayne ASTRONOMICAL formerly worked in optical and radio astronomy in Australia, New Zealand and Thailand, and is now an adjunct professor of astronomy in the Centre for Astrophysics at the University of Southern Queensland. He has had wide-ranging research interests and has published extensively with research papers on the history of cometry and meteor astronomy and meteoritics, and the early development of astrophysics, historical eclipses and the development of solar physics, historical transits of Venus, historical telescopes and observatories, amateur astronomy, and the amateur professional interface, electro astronomy, Cook voyage astronomy, and the history of radio astronomy. Gosh, there's a thing to write home about. Wayne has written an extensive number of books and edited many more, and has recently been exploring the history of Southeastern Asian astronomy, and also co-authored many books, one of which is The Golden Years of Australian Radio Astronomy, co-authored by Peter Robinson and Woody Sullivan, both of which were published by Springer in 2021. He is one of the most active members of the IIU and is currently intermediate past president of the Commission for C3, the History of Astronomy. He also co-founded the Journal of Astronomical History and Heritage and is the current managing editor, and of course was involved in the resurgence of the journal when it was possibly going to finish for good, and we're very glad that Wayne interceded. And believe it or not, he has a piece of real estate orbiting the sun. He has an asteroid, a minor planet named after him, 48471 Astraton, a piece of real estate that no one could get their hands on. And he was awarded the Donald E. Estabrook Book Prize from the American Astronomical Society for their book with Stella Cosram, Eclipses, Transits, Comets of the 19th Century and How America Perceived the Skies Changed. That was published by Springer in 2015. Now, it would be amiss of me if I wanted also to introduce Mrs. Darunee is a successful businesswoman in Chiang Mai, Thailand, and also doubles as Professor Wayne Ostraton's part-time research assistant. She has a special interest in ethoastronomy and was taught traditional Lara astronomy by her father, a medical doctor, and her grandfather, a businessman. Darunee has a particular research interest on Philippine and Thai astronomical history, Thai meteorites, Indian, Maya, and Ethiopian astronomy, engaged in archive work, data collecting, and field work in Australia, France, India, Singapore, and Thailand. She has co-authored many research papers and have been published in the Journal of Astronomical History and Heritage, and has been involved in 4 different books. The collaborative title of their talk today, this is a review paper. We briefly discussed the first introductions of the telescope into Southeast Asia in the 17th century and historical significant telescopes of my Allen and industrial observatories. We will then look at the design of Hindu and Buddhist temples and the special role of the Hindu sun temples before examining the total eclipses of 1868, 1871, 1875, and 1929, and the key roles they play in the development of solar physics. Finally, we turn to the special potential that Southeast Australia offers astronomers and focus on unraveling the changing astronomical systems of the different ethnic groups found in the Philippines. And if I've left anything out, I do certainly apologize. So ladies and gentlemen, please welcome Wayne Ostraton and his wife, Darunee Ling. Thank you very much.
Well, thank you very much, Gerard, for that charming introduction. Me and my wife. And what I'll just like to say is that it's a delight to finally be presenting this after illness stopped me from doing so earlier in the year. But as you can see, I'm still alive and well, so hopefully we can enjoy this talk even if it's slightly delayed. I thought that before I move from this title slide, I should just mention 2 things. One is Darunee LINGLING ORCHISTON is not going to do the presentation, I'll do the whole thing. So I thought you should know, those of you who haven't met her, you should know what she looks like. So I've included a picture of her here on the title page down the bottom left. And the second thing is I've gone and also indicated that thanks to the University of Science and Technology of China, I can now list them along with the University of Southern Queensland as my affiliations. Gerard talked about the fact that the Journal of Astronomical History and Heritage was in danger of closing down or being sold to Springer. And the outcome of various negotiations was that the Chinese university, which is the national one for science and technology for China, kindly agreed to take over the journal, and they are now employing me as a co-editor. So it's a delight for me to give this presentation representing not just the University of Southern Queensland in Australia, but also the University of Science and Technology in China. So let's just move on and have a look at what I want to cover, which Gerard's actually foreshadowed. So there'll be some introductory comments. Then we're going to talk about the link between Southeast Asia in terms of prehistory and history. This is going to provide a framework for the astronomical account that comes later. And when we talk about Southeast Asia, just as part of the introduction, we've got a map here, which you can see on the right-hand side. And all of those areas in green represent the countries of Southeast Asia that are relevant to this talk. So running from the left to the right, there's Myanmar. Then we've got Thailand, or Siam as it was for much of the time that we're going to be talking about. Beside that, we've got Laos, Cambodia, Vietnam, and then down into Malaysia, Singapore, Indonesia, Philippines, and that basically is it in terms of ASEAN countries. So we're going to talk a little bit more about introduction, then we'll go on, we'll talk about the four main themes: telescopes and linked to them observatories. I won't say much about that. Temples, I won't say much about. I could give a whole 1-hour lecture on each of these. Eclipses we'll talk quite a bit about, because that's an area that Darunee, Lingling and I have done quite a lot of work on. And I want to spend the rest of the time, which will be about half the presentation, talking about ethnoastronomy. That's the astronomy of Indigenous peoples, because I think that is where there's very exciting work that there has been done already and will be done, especially once COVID has disappeared. And then we'll finish with some concluding remarks. So an introduction. What I'm doing here is talking about history of astronomy, ethnoastronomy, and archaeoastronomy. They're all areas that come under the preview and purview of the IAU Commission C3 History of Astronomy. So this is a wide-ranging area. And as I've said, we're going to be talking about traditional history of astronomy, also archaeoastronomy. I like to talk about Southeast Asia in an international context, and we can see on the map, we've got our bullseye, which is centered on Southeast Asia, but also we're going to be talking here about the link between Southeast Asia and China, and also linkages with India. There's another area of linkage which I won't be discussing in this paper, maybe another one in the future, is the link between northwestern Australia and Indonesia. So that's the geographical area, and you'll see these international linkages coming up in the course of the presentation. One of the things that I think is unique about the sort of work that Darunee, Lingling and I do is that we try and interpret history of astronomy in an international, multidisciplinary context. So it's not just a matter of looking at astronomy from a historical perspective, it's a matter of trying to bring into the equation subjects like anthropology, genetics, history, geology, linguistics. You know what all of those mean. Paleoanthropology, which is the study of ancient humans, particularly skeletal material. Prehistory, which is archaeology. And paleoclimatology, early changes in climate. And so what we do is, with the kind of work we're doing, we try and combine information from all of those. Now, I'm very fortunate that I just happen to have a background in all of those, an academic background, a research and teaching background, publication background, and all of those except linguistics. So I can combine a background that links in with astronomy in this rather unique way, which is rather delightful, and then bring in Darunee Lingling's ethnoastronomical background. Just to show the one area that I'm not talking about, which is linguistics, we've got a diagram on the bottom right there, which shows the different subgroups within the Austronesian language family. And you can see that that extends, different areas extend within Southeast Asia and then right across into the Pacific, in fact, to New Zealand. So one of the thrilling things that I'm doing with some of the work, and Darunee Lingling's linking in with me on this, is looking at the relationship between the astronomical systems, for example, of the Philippines and a part of Indonesia with the Maori. and we've published a number of papers on Maori astronomy, and we're now trying to link those together. So it's wonderful to be able to link these different areas and also look just beyond Southeast Asia from a regional perspective. And I think you'll see once we go through this presentation that really this whole area of Southeast Asia presented in this way provides wonderful research potential, really almost a unique field of opportunity. So I'll be talking here as Gerard has indicated, I'll be talking about current research, previous research, and because of COVID, I'll be talking about future research that we would have liked to have done, which some of our colleagues who are actually here in the audience from the University of the Rizal University in the Philippines, for example, that some of our colleagues would have that will happen soon once COVID has disappeared. And similarly, we've got field work to do and with colleagues in India, so there and more in New Zealand. So unfortunately, this is research in progress, but that's all right. We've got lots to talk about. So definitions, you all know what temples are, you know what telescopes are, you know what ethnoastronomy is. I've already talked to you about that. You know what eclipses are, but do you really know what astronomy is? I've got some definitions here I thought that you might like to enjoy. I personally like the one at the bottom best. So it's important for us to understand what astronomy is all about, and we need to take a light-hearted view if we're going to really enjoy this kind of presentation. So let us now move on to topic number 2, Southeast Asia, and we're looking from prehistory to history. I want to talk about various aspects here. I want to talk about the changing environment, and then I want to talk about the changing people within that changing environment. So we'll start by looking at changing environment, particularly in relation to glacials and interglacials, and the way in which this impacted upon climate, temperatures, and rainfall. And if you look at the top diagram here, and if I use my pointer, can you see that? That's visible. Okay. If you have a look at this period that we're going to be looking at, is from about 70,000 years ago, which is here, through to the present day, which is there. You can see that we're at a time which is relatively warm in terms of the history of the world and of Southeast Asia. Most of the time when humans were in the area of Southeast Asia we're talking about, in this area here, the climate was considerably colder than the present. So we want to bear that in mind. We are looking at an anomalous period in terms of human history, and the way in which temperature, rainfall, and climate impact upon humans is really important if we're going to look at changing astronomical systems over a period of 50, 60, 70,000 years, which is what we're hoping we can do with the kind of approach that I'm talking about. If we want to look just at this recent period here, just at the period from the last 20,000 years ago to the present day, even within that period, we've got major variations taking place. So here on this diagram here on the bottom left, we've got a system here that runs from about 12,500 years ago. Ka means 1,000 years ago. 12,500 years ago back here, tracing up here, and you can see the way in which the temperature is varying by several degrees. It's oscillating quite substantially during this period here, and then a major drop in temperature and a very sudden rise. And that takes place back about 3,500, 4,000 years ago. So even when we're looking at the recent period, we're still looking at changes taking place in temperature. And that, of course, impacts upon the kinds of plants and animals that live in particular environments, which then impacts upon the habitats that humans occupy. It influences their culture, part of which is astronomical systems. So their astronomical systems are impacted by the changing temperatures, changing rainfall. And if we want to look at this in further detail, we go across to this right-hand diagram here to what's called the 4.2 Ka event. So from about 4,000 years ago through to about 3,800 years ago, we had a period when we had an anomalous amount of drought. So all of the red bars and the yellow shading indicate extensive periods of drought year after year, preceded back here by a period of intense rainfall, heavy rainfall. So we've got floods here, we've got a period of great instability here, And then this period here, and extending on actually to the left of where we show, we've got a period of extreme drought. So this 4.2 Ka event was found throughout the world, not just in Southeast Asia, but in the areas of Southeast Asia where you've got a dependence upon the monsoon climates for survival. A 4.2 Ka event is absolutely critical. It is about terms of interpreting the astronomical systems of Southeast Asia. So let's move to the next slide. The other thing, and I hope that you can see this, I've got a note up on the screen saying my internet connection is unstable. Can you still hear me? Can you still see me? Okay, fine.
Yes, yes to both questions.
Thing that's absolutely critical, even more so than temperature and rainfall and droughts, is sea level changes and land bridges. And if we're looking at this map here in red at the bottom, we've got a time period from about 120,000 years ago here, tracing through to the present day, 0. And what this is showing, the curve is showing the way in which the sea levels varied in this Southeast Asian part of the world during that period. So the earliest humans of the modern type, Homo sapiens sapiens like ourselves, arrived around here between 60, 75,000 years ago. We can see that the sea is significantly lower. Here's the present sea level here. The sea is significantly lower at that time than it is at present. And it remained lower, and then it trended downwards rapidly from this period from about 55,000 years ago to about 30,000 years ago. And then it dived down to a low sea level of about 125,000 meters below the present, 22,500 years ago. And then from there, it went zooming upwards very quickly, reaching above the present sea level about 6,000 years ago. And then it moved down to the present sea level. So the thing to take home from this is that the sea levels that we've got around the shores of Southeast Asia, England, and everywhere else that the people are watching this presentation, the sea levels we've got, the shores that we've got today are very recent. They only date to the last 6,000, 5,000 years. Before that, the sea levels were lower. Areas that are now underwater were above water at that time and were part of the land. And to indicate just how significant that is in Southeast Asia, if we look at this map, this whole area here, represented by white, shows where the sea level would have been, where the shoreline would have been 22,500 years ago. So we can see that the mainland of Southeast Asia, Thailand here, Malaysia, Singapore, and then islands of Borneo, Sumatra, and actually under the map, the island of Java, which is across here, all of those actually were part of the extended Asian mainland, which we call Sundaland or Sundaland. So they weren't individual islands anymore. They were part of one large, enlarged, extended Southeast Asian Australian landmass. Similarly, if we go across to the right here, we've got New Guinea, which is now separated through here, through the Torres Strait, from the very northern tip of Australia. But that was all part of one large landmass that we call Sahul. So New Guinea and Australia were connected. And for humans, 65, 70,000 years ago, when the sea levels were lower, so in fact there were greater water gaps, they had to traverse major water crossings to get to the Philippines, here, 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 or this way. Or to get to Australia, they had to cross these links between these islands and then go across to Australia, or they could do it this way or maybe that way. And here on this little map, maybe you can't see it, but I've got in black, I've gone and outlined all of the locations where significant water crossings were required to get to areas of land back in the times when prehistoric man was trying to settle part of Southeast Asia that we're looking at. So there was never, ever, ever a land bridge directly between the enlarged Southeast Asian mainland and the Philippines. And there was never directly a land bridge between Southeast Asia and Australia. So when we talk about the world's first mariners, it's not the Vikings, it's not even the Maori and the Polynesians who settled the Pacific Islands. It's these people who made these land crossings 50, 60, 70,000 years ago. They are the world's first mariners. So I've got the very best situation when the seas are at the very lowest here. So this is this point here, about 22,500 years ago. But of course, the sea levels were not as low as that back in the times when most of these settlements were taking place. They were here. So in fact, the shoreline would have been back in here. And the water gaps would have been even larger. So you can see sea levels are absolutely critical for our understanding of this. And the way in which the sea varied during that period, say from 25,000 years ago to 12,000 years ago, is also critical because the seas were moving so quickly that within a generation, a human population living on the shore would actually see the sea recede or see it move inland. They would have to change the position of their settlements. They would have to change the position of their fishing grounds, of all of the land-based exploitation areas. And depending upon what other areas were available, they might have to even change significantly the type of diet that they needed for survival. That, of course, would then, as we'll see, impact on the astronomical systems, because the diet of people and their ecology, the way in which their human relationships are with their environment is reflected in the sky. And we see that in many different astronomical systems, including in Southeast Asia. So what's on the land, what's important on the land is also there in the sky, named in the sky and explained in the sky. So if you're going to change your ecology, change your hunting patterns, change your agricultural patterns, change your location from one site to another, that should and could be represented in the sky with changing astronomical systems. Let's now look at the different humans that occupied the Southeast Asian area. We're not going to be talking about this period because this period is from nearly 2 million years ago through to about 50, 60,000 years ago. And it's before the time of any of the humans that we've got astronomical information for. So we've got 4 different types of hominids or early humans found in this area. And remember, the sea levels are going to be different. So some of these areas that are islands would also have been parts of mainland at that time. And I've gone and shown with the white dots and the names some of the very early archaeological sites where we've got human skeletal material or where we've got artifacts that we know date back to a period of, well, 500,000 to several million years ago. This is an area that I actually used to do research on, and I did a lot of work in Indonesia on this back in earlier days in the 1960s and 70s when I was a young man. So we've got early humans and we've got a lot of documentation, a lot more than I've shown on the map, but that doesn't influence us and it doesn't really interest us very much if we're talking about astronomy. Because what we need to do is look at the 3-phase system, which looks at the appearance of modern man, Homo sapiens sapiens, within Southeast Asia during a period from about 70,000 years ago. And what we call, initiated by what we call the out of Africa hypothesis, which postulates, and the evidence is overwhelming, that the earliest modern humans originated somewhere in the this area of Africa, northeastern Africa, and then they migrated along what would have been the coast, anywhere between 170 and 170,000 years ago, along the coasts, and then into Australia. And they also went into the Philippines with water crossings required in each case. We talked about the earlier people, and to show the physical differences, I've got a diagram here, which on the left shows Homo erectus, the early form of hominids from this area of Indonesia, of Java, that I was researching back in my earlier days. This is dating about 1 million years ago, this type of a skull. And here we've got the skull of a typical modern man, Homo sapiens sapiens. So you can see the cranial morphology is really very, very different. And also the brain size, cranial capacity is different. So the first humans occupied our area of Southeast Asia around about 70,000 years ago when Sundaland existed. So we are looking at this green area here, a much enlarged East Asian landmass. And water crossings were required, as we said. And then and we call these people originally, we call these original occupants the Australo-Melanesians. They were hunter-gatherer people, so no agriculture or horticulture. This comes much later. And these Australo-Melanesians are now found only in New Guinea and in Australia, nowhere else. So originally they were through here, but they've disappeared. And we'll explain why a bit later on. And then about 4,000 years ago, we have a major change taking place, which we can see represented by this diagram at the bottom here. We've got people that were called Austronesians, rice growers. So here's the first appearance of agriculture. Rice growers coming from South China originally into Taiwan. And then they moved from Taiwan into northern Philippines, spread throughout Philippines and into Borneo. And then eventually Austronesians settled in this area here are thought to have then migrated out north of New Guinea and off into, this gentleman is just sitting here, off into Polynesia, and eventually they became the Maori of New Zealand. So that's why I talk about the linkages between Indonesia and New Zealand. There's a direct link there because Austronesians were found in both places. And they arrived about 4,000 years ago. And it's now thought that maybe the 4.2 Ka event was what caused that outmigration from Taiwan, that there was population pressure on land because the resources were depleted because of the succeeding droughts over hundreds and hundreds of years. And so some of the people said, okay, let's find a new home where maybe there's no one around, where we've got some food we can survive. And then the third group of people that we've got settling this area, but not the northern part, not the Philippines, are the Austroasiatics. They're also rice growers, and they came from South China through down through Vietnam and along Malaysia here and into the southern parts of island Southeast Asia, so into southern Indonesia, but they never migrated north into the Philippines. So if we're looking to try and differentiate different kinds of astronomical systems in Southeast Asia, and we want to separate the Austronesians from the Austroasiatics, we can say, okay, in this area here, we've only got Austronesians. In this area here, we've only got Austroasiatics. In this area here, we've got both. So let's look at the different astronomical systems and see if we can identify components of each of those systems. Those are the sort of things that I'm trying to do now with various international colleagues and collaborators. Okay, that's what we call the three-phase model or three-phase settlement model. As I'll indicate later, this is all total garbage. Just in the last couple of years, as a result of new genetic material, mitochondrial DNA and Y chromosome evidence, we have shown that this is actually totally simplistic and it's not possible to carry out the interpretations using the three model systems anymore. There's a lot more complexity to it than that. And this is one of the problems of giving a lecture like this, that if I give this in a year's time, there'll be more evidence, particularly from genetics and also hopefully from ethnoastronomy, and we'll be able to provide yet a different interpretation to what I could give today. But that's the basic model that until a year ago, everyone was using. That's the basic model that we used when we wrote this book here, which Gerard talked about. So that was written in 2021, and that's the interpretation of Southeast Asian astronomical systems is based upon this model. I've just, together with colleagues from the Philippines, from Rizal Technological University, just in June this year, we published a paper that has ethnoastronomy in it, and we've tried to interpret the material from the Philippines in terms of the new model, which we will look at later, which has very little to do with what we've just seen. So this is the old system. This is when it was convenient and easy to actually try and interpret astronomical systems, but even that was complex enough. It'll be fascinating for you to see what we're looking at now. So we've got change taking place with humans, and then we've got further changes taking place with humans and also with human theology and this sort of thing, ideas rather than people. So in more recent periods, within the last 2000 years, we've got the invasion of island Southeast Asia and mainland Southeast Asia by Hindu and Buddhist religion, and then by Islam. And so we've got two diagrams here. The one at the right top shows the spread from different areas of India of Hinduism, and also to some extent Buddhism, into Southeast Asia. And we can see that if we're looking at the areas that we're interested in, there's enormous focus on the island of Sumatra, which is here. And look at all of these centers of settlement for Hindus in Java, in Indonesia. And then we've got two little areas here which really weren't much impact. But when we look at Islam, we find that this whole area of, well, actually, basically this whole area here of Southeast Asia is now almost entirely Islamic. And even this southern part here of Mindanao in Philippines is Islamic. Here it is here. And Palawan, the island of Palawan. So we need to allow for the fact that superimposed upon the earlier astronomical systems, we've now got new astronomical systems that are native to Hindu religion, Buddhism, and Islam. And that's important. Then superimposed on top of that, we've got colonialism. So this map on the left-hand side shows the situation maybe 200 years ago with the British in Burma, the British trying to take over the whole of what's now Malaysia and Philippines and northern Borneo. So all of these areas in purple or in blue or in red are British. Then we've got the Indonesians. Those days they were called Dutch East Indies. So we've got Dutch colonists occupying most of what is now Indonesia. Originally we had the Philippines as a Spanish colony. Then from 1898, it became an American colony. So and then over here, we've got this whole area of what was called Cochin China or Indochina, which was territory of the French. And just notice, because we'll come back to this, look at what's sandwiched in between the British and the French. Siam, the only country, the only area in the whole of Southeast Asia that was never actually colonized by any colonial powers, except of course the Japanese during World War II. And we're going to come back to this. We're going to come back to this meat in the sandwich later, because this is interesting. And you'll see that astronomy, history of astronomy, is far more than just about astronomy. It's also about politics. So we've got to interpret the astronomical systems of Southeast Asia, not just in terms of the early settlers 70, 80, 60, 70,000 years ago, the arrival of agriculture, which has a major impact 4,000 or 5,000 years ago, but also the different religions. So it's introducing concepts of theology rather than mass movements of people, which the earlier settlements occurred. And then we've got colonialism. And again, that's the movement of not large numbers of people, but it's also movements of ideologies. So all of that is basic to what we're talking about, astronomical systems of Southeast Asia. Let's now move on to some of those and just look at some of the areas that are being researched at the present time, have been researched and need to be researched. So one of the things that interests me worldwide, not just in this area, is historic telescopes and as a corollary observatories. And one of the things that's fascinating is to look at the introduction of the telescope. 1608, 1609, we see it spreading throughout Europe and Netherlands and adjacent countries. When does it arrive in Asia? The earliest evidence is actually in India, 1618. But what about in Southeast Asia? We've got no evidence yet, and that's because there are so few of us carrying out work. And it's almost certainly going to be associated with Jesuits, because they were the first Westerners who were carrying out systematic scientific Western type astronomy and came with instrumentation that they could use in that way. And we know that the Jesuits in 1685 were using telescopes in Siam, in what's now Thailand. But there were Jesuits even earlier in Thailand that we're still doing research on. And there were Jesuits much earlier in Vietnam and also in the Philippines. So one of the things we need to do is systematically go through the records of these Jesuits, analyze not only their astronomical work, but also what instrumentation was being used. So that's a big question mark. Where did the Jesuits introduce their earliest telescopes in island Southeast Asia? We don't know. Hopefully in 2 years' time, we will know and we can give a different lecture. Historical observatories and telescopes. One of the things we need to do here is look at the impact of World War II, because one of the most famous observatories of Southeast Asia was the Manila Observatory, founded in 1865 by Jesuits and destroyed entirely by bombing of Manila in the Philippines in World War II. Again, this was a Jesuit observatory. So here we've got Jesuits in 1685. Well, we've got Jesuits here in the early 1600s. We've got Jesuits here in the 1800s in Southeast Asia. So one of the themes that comes through when I'm looking at other different research areas to investigate is the whole impact of Jesuit astronomy throughout Southeast Asia. And I'll talk more about that in a minute. So here we've got some historic photographs. At the bottom left, we've got one of the main buildings of the Manila Observatory before it was destroyed. And here we've got, on the right, we've got the 19-inch refracting telescope that was used. But what do you do with a telescope if you're living in a place that's plagued with monsoonal rain and then clouds? You don't get too many opportunities to get a beautiful clear sky. And if you've got it, if you're in the middle of a city, what do you do? Well, the Jesuits in Manila, they focused on meteorology and they published on that, and they became well known as chasers of typhoons, of which the Philippines has the record as being the world's leader in terms of experiencing typhoons annually. The other observatory that's fascinating is Boschke Observatory in the Dutch East Indies in Indonesia, near Bandung, which is quite near the capital of Jakarta in the Java, the main island of Indonesia. And in 1923, two rich businessmen, tea planters, and also interested in astronomy, amateur astronomers, founded Boschke Observatory. They provided the funding. They set it up as a professional observatory with professional staff. So it's got the very best instrumentation from Europe. So here at the bottom left, we've got a 24-inch twin refractor from Zeiss. One of the telescopes was used for photography, the other for visual observations. There's other large telescopes, including, 17-inch refractor we can see here on the right, and astro cameras. And here we've got at the top left, we've got a photograph of the observatory with different buildings, headquarters, and various observatories. This is the one for the 24-inch twin refractor. Now, this is set up as a private observatory. Following independence of Indonesia in 1948, it then became the National Observatory of Indonesia. And notice the date, 1923. So next year is the centenary of Boschke Observatory. That is really, really relevant to what I'll be talking about later, because next year is not only the Boschke Observatory centenary, it also happens to just be my 80th birthday. And so what we are planning through the Indonesians who now run this observatory is to have 2 international conferences in Indonesia, one celebrating Wayne turning 80, but we're turning that into a much wider conference about Asian and Southeast Asian astronomy, history of astronomy. The other will be celebrating Boschke's observatory, and not only the development of the professional astronomy there, but also the inauguration of their 3.7 meter new telescope, so the largest in Asia, not just Southeast Asia. So Indonesia is really leading the world in terms of Asian or Southeast Asian astronomy, professional astronomy in this way. And the last thing I just want to mention here is, see down the bottom on the right, we've got astro cameras. So we've got a 7-inch refracting telescope as a guide scope, and we've got these astro cameras mounted. One of the things that the Boschke Observatory did during the late 30s and 40s was to liaise with and carry out research collaborations and variable star research with Riverview Observatory, a Jesuit observatory in Sydney, Australia. So here we get, again, we've got the Jesuits, this time in the 1900s, this time in Australia. So one of the things I'm interested in is looking at Jesuit astronomy from India right throughout Southeast Asia to Australia and then up to Hong Kong. A beautiful scheme, looking at that from the viewpoint of scientific astronomy, but also from the perspective of Jesuits as a Roman Catholic approach to astronomy. And for me as a Buddhist, that's a very interesting, theological approach. Right, so let's move on to temples. We've got Hindu and Buddhist temples, as we saw from our map earlier, scattered throughout Myanmar, which is used to be called Burma, Thailand, which used to be Siam, Cambodia, Kampuchea, Malaysia, which was Malaya and Indonesia. Malaysia and Singapore, Indonesia, which used to be Dutch East Indies. And we've got information from these with inscriptions, and there's been a lot of research carried out by historians, not just by astronomers, looking at the dating and the astronomical links between different temples. And we've got a number of temples which we call the sun temples, and we've got an example of one of these here, which is actually an example from Thailand, but very close to the border with Cambodia. And we call these sun temples because 4 times a year, twice during about 3 days of sunset and twice again during 3 days of sunrise, separated by 6 months, we've got the sun particularly aligned at rising or setting so that it actually shines through the middle of the temple and illuminates all the different rooms and areas within the temple and illuminates any statues that are there or used to be there. So this is an area where there's a chance to carry out interesting research linking the sun temples of Southeast Asia, and particularly Cambodia and Thailand with India. And we've got people working on that at the present time. We've got down the bottom here, Borobudur, bottom left, and Prambanan, bottom right, both of which have been researched by Indonesian colleagues, astronomical colleagues, by Taufik Hidayat from the university that's now organising the Sposhka Observatory Conference and next year. And so he and his graduate students have been doing research, and undergraduate students actually also been doing research on the astronomical alignments and astronomical significance of these different kinds of temples. And there are dozens and dozens and dozens of these temples scattered throughout Indonesia, and also some of them in Malaysia too, that are just waiting for attention. So this is an area which is really, really useful. And one of the problems, of course, we have if we're working on history of astronomy, you look at the audience. Who do I see there? Jay Pesakoff, Wayne Orchiston, Gerard Gilligan, Nick Lom. I see all these geriatrics, all of us people in our 70s and 80s, and some of us in our 90s if we could still alive. We all get into history of astronomy when we become old, and we become part of the history of astronomy, don't we, Jay? I can see you smiling there. How do we get the young ones in? Because there's no jobs in history of astronomy. Well, what's happening now is that people like Taufik Hidayat at Institute Technology Bandung in Indonesia, and Ray Guido, who's head of astronomy, and Ruby Ann Dela Cruz, also head of astronomy at Rizal Technological University in the Philippines. What they're doing is they're getting undergrad students and their postgrad astrophysics students to carry out small-scale sideline research projects and to publish papers on these projects, and to also give international conference presentations. So that conference next year, there should be lots of those sort of papers. That's really interesting. So these students will end up, most of them, getting jobs in astrophysics because that's what they're trained for. But when they go for jobs, and even when they go for postdocs, or even when they go to get PhD scholarships, they've got an ethnoastronomy or an astroastronomy string to their normal astronomy astrophysics bow that they can use to strengthen their application. And when they've finished their PhD and they go for a job, they not only go for a job in the research observatory or in academia, they can go for jobs in science museums and planetariums and places like that, where they can focus on their ethno and archaeoastronomy. So I think this whole idea that Taufik is adopting and that Retail Technological University is following is an excellent one, and we should be trying to encourage our academic colleagues in astrophysics to do much more of that around the world. Jay, I'm sure, is doing that with his undergrad students, taking them on eclipse expeditions all the time too. So the enlightened people are doing this. We need to get more enlightened professional astronomers. But lots to do with temples. And what I haven't talked about, of course, is this main one on the top left. This is from Bagan, which is an area in what used to be called Burma. And Burma, if you go there, it's now called Myanmar. It's just absolutely constipated with temples, with Buddhist temples. They are there by the thousands. And if you stand and take a photograph like this one, you don't see the detail, but there are about 50 temples actually within the small scope of the lens just in this photograph. And all of these have got documentation. The historians have gone and documented when each one was built. They've got all that information. What we can do now is actually use that information and link it in with astronomical interpretations of these temples. This is wonderful. This is something I've been trying to get the astronomers in Myanmar interested in. I've gone and given seminar papers there. They're all fascinated, but nothing ever happens. It would be wonderful to find a master's, or a whole lot of them, or PhD students interested in doing these research projects for their theses. I can't find anyone yet. So there is an absolute treasure trove of research there, just Pagan alone in Myanmar in Buddhist temples. There are plenty of them in Thailand as well. What interested me in the course of my travels over many, many years, when the first time I visited the island of Bali in Indonesia. Once you go away from the tourist centres and you go into the highlands, into the mountains and the lakes and the mountains, you find there are two completely different kinds of Hindu temples. And in fact, Bali is unique within Indonesia. It's the only island where the entire population is non-Hindu. Is non-Islamic. They are all Hindus. They are all Hindus, and Hindu religion is the traditional, the base religion for that island. And when you go to the non-coastal touristy areas, you find there are two discrete kinds of Hindu temples. We've got the one on the right, which is the more typical one. And then in the mountains and amongst the lakes, you've got these ones shown on the two photographs that DARUNEE LINGLING ORCHISTON took when we were there a few years ago. And they are modeled on either 9 stories, so the 9 levels of heaven in Hindu mythology and religion, or 3. They're 3 or 9. You'll see that throughout. Here's 3. And this is another research project I've got on my list. And in fact, next time we go to Bali, we're hoping that we can link in with some local Bali people and we can carry out research on that. But another research project, and then how do you differentiate between those temples and the ones shown on the right? They've obviously got different functions, they're different architectures. Have they got different astronomical associations? I don't know. No one knows. There's so much we don't know about Southeast Asian history of astronomy. Let's talk about eclipses. This is an area where DARUNEE LINGLING and I and various colleagues from Australia, from Sweden, from France have carried out a whole range of research, and colleagues also here in Thailand. So our research started actually by looking at the earliest evidence of eclipses carried out with scientific observations. And again, we get back Jesuits. The first observations of lunar eclipses were carried out by Jesuits in 1682, 85, and more in the 1680s. And then the first solar eclipse again by Jesuits in 1687. So the Jesuits are carrying out these observations. The very first eclipse that we've got documentation for was carried out by Father Antoine Thomas, who's from Belgium. Most of the Jesuits that we've been researching are from France. So it's been really good to be able to speak and read French and go through the archives in Paris, which we were doing until COVID stopped us finishing that research. But Father Antoine Thomas, he did his training in Spain, so he was a Spanish speaker. He wasn't French speaker, and he carried out the first Western type astronomy that we're aware of. But I've got a suspicion there was someone before him that we are researching at the present time, and he was the first one to determine the longitude of Ayutthaya, which is one of the two major capitals, international cities of Siam back in those days, and we can see them marked by the blue and the green circles there. And he was able to do this research because King Narai, whom you see at the top left, was an amateur astronomer and carried out astronomy where possible, and also patronized the development not just of local astrology, which was part of the state system, but also scientific astronomy. So he encouraged Westerners to come to the Siam and carry out astronomy. And this was no more better so than in December 1685, when 6 French astronomers carried out observations of a total lunar eclipse from Lopburi, the other one of these two locations. It's the green circle up the top. Carried out observations of this eclipse with King Narai in December. 3 o'clock in the morning, so the moon, which is depicted on this drawing, is low in the sky. This drawing is actually total garbage. It's based upon reality, but the person who drew it has never been to Siam, never saw the thing, and just relied upon reports from the French astronomers. So he's even got the room in which the observations were made modelled as a temple. It wasn't, it was one of the buildings within the actual palace where the observations were made. And the observations involved were with the first optical telescopes we can document so far with Siam. So 1685 is the first proven evidence of use of telescopes. And as a result of those observations, the French were able to carry out investigation of the longitude of Lopburi, and they used Cassini's map of the moon that was prepared especially for this series of observations in 1679. And we can see that. We can see that map of the moon on the bottom right there. And the moon map we can see on the top left, top right, has got red dots on it. These are some of the sites where the French astronomers timed the movement of the shadow of the Earth as it moved across the moon and recorded those. And we can now use our present ephemerides, and we can compare their times with the modern times that we can calculate. And we've got that represented here in this diagram. So they were up to about a second and a half too early to about a second too late. So we can see their time's pretty good altogether. And Darunee, Lingling and I were really interested in this. We were able to, from looking at all the documentation, including unpublished material, we were able to pin down the fact that these observations were not carried out at the main palace of the king. They were carried out at what was called his country retreat, which was a palace beside an artificial water reservoir that had been set up to provide water for Lopburi city. And there was an island there right on the border of the reservoir, and he built a palace there. And he also carried out astronomical observations from there. And by going there and looking at the picture that we showed you on the previous slide, and also looking at the design, the layout and the descriptions, published and unpublished, we were able to pin down the fact that his observations were carried out here, from this building through this window here. And so across here to the left is where the moon would have been visible at 23 degrees up from the horizon. And then on this area out here, just off to the left, we've got that courtyard. I'll go back actually. So we've got the water reservoir here, and then we've got this narrow terrace between the king's room here, where the Jesuits were located. So we've been able to pin that down, and we've actually included details and descriptions of that. This is what the palace looks like today. And there's no lake around it, but there's swampy land, and the bank that was built by the Italians who actually built this whole water reservoir, this 4-meter high bank which extends for many kilometers, you can still trace that, and you can actually drive along one of the roads that goes along the top of part of it. So we've surveyed all that, and it's interesting to actually link the historical material. That's why I say we also got to link historical information back with astronomical if we want to get a full account of some of this work. Now, the consequence of this observation was really amazing, because the king was absolutely fascinated by the kind of research that could be done in scientific astronomy. So this is why he ended up getting Jesuits to come, in fact, 2 different contingents of Jesuits from France sent by the king to support Southeast Asian astronomy. And as well as that, the king from France, as well as the king in Siam, they funded the construction of an observatory, which we can see on the bottom slide here, as well as a major building which included a school and residences and offices and all sorts of other non-astronomical objectives. But the main function here was the observatory, which we can see here, a multi-story, 4-story observatory, tower observatory, which was modeled on, sorry, the 2 towers at either end of Paris Observatory. And in 1760s, the Myanmar, the Burmese invaded Siam, and they ended up destroying most of these early sites, including this one here, but there's still the remains of part of this tower observatory. There's 2 of the 3 stories still surviving, and there's also the foundations of part of this, and the half of this whole building here is actually now an historic reserve and is preserved by the government and interpreted by them. So a fascinating place if you want to go and study this. You can go and see an interpretation of this site, and you can also go to the to that other temple that we see above there and have a look at the remains there, which has got far more than at the observatory, which is called Wat Sao Polo. So that was the start of looking at eclipses in Siam, and we've studied all of the eclipses that are, I think, that are relevant, both solar and lunar, now as a result of our interest. What has particularly interested me for quite a few years is what I call the watershed event, solar eclipse of 1868, 18th of August, which is one of the most important events scientifically to have ever been observed by astronomers anywhere in the world. And the path of totality we can see here with the eclipse path, with observations made from Aden in the west, a whole lot of different observing sites, more than the 4 shown there in India, one place, one location in Siam, one near Borneo, and one in Indonesia, Dutch East Indies. And I've been carrying out research with Indians, colleagues and collaborators. So we've published a number of papers about the Indian observations. DARUNEE, LINGLING and I have researched the observations carried out here in Thailand, and with collaborators from Indonesia and also from Germany, we've carried out research and published 2 papers about the Indonesian observations. The key discovery of this eclipse, of course, as Jay would tell everyone, is the discovery of helium. And the discovery was not made by Janssen, which everyone seems to think if they go and read, because the truth is actually it was made by Pogson, who's the director of Madras Observatory. But Pogson was having a feud, not that he knew it, with the Astronomer Royal Airy, who ended up blocking all of Pogson's attempts to try and document his observations and discoveries made during this eclipse. And Biman Nath, a astrophysicist from India, and he's published a whole book about this, and we've also published a detailed research paper about this in the Journal of Astronomical History and Heritage, providing documentation for this. And those of you who attended my lecture to the BIA historical section a few months ago, we actually discussed this, just this eclipse. The whole lecture was on this, and we talked about that in detail. A fascinating story. But that's not part of Southeast Asia. So we're just going to focus actually on the 2 of the 3 right-hand red circles, the observations carried out under King Rama IV, another king interested in astronomy, and also in the Dutch East Indies by a person there who was involved in astronomy professionally. So we've got King Rama IV. This is another astronomer who's a patron of professional astronomy and carried out observations himself. He actually used traditional scientific as well as local astronomical information to compute the eclipse path of this eclipse. And his eclipse location was on the dot. It was exactly where the French ended up basing their expedition. So he invited an expedition, people from France, from Marseille Observatory and also Paris Observatory, led by Stéphane, you can see there on the left of the three, the director of Marseille Observatory. And Rayet and Tisserand, both of whom would become very well known. Rayet, Wolf Rayet stars, of course, named after him. Now, and the reason that Rayet was there, because they were carrying out spectroscopic observations as well as visual. And he was meant to interpret the spectra, but unfortunately, he was an expert in stellar spectra, not solar spectra, and he missed the interpretation of what was the helium line. He assumed it was just one of the sodium lines. So had he discovered the helium line, then he would be much more famous as a discoverer of helium than he is as a co-discoverer of Wolf-Rayet stars. Sad story. Okay, so we've got three of them. They've provided with lots of support by King Rama IV. So King Rama IV had his architects go and build different constructions, which we can see here in this right-hand slide. And the various telescopes were set up, but unfortunately there wasn't enough room in them for the two, the 18-inch reflecting telescope and the smaller one, which we can see actually out in the open there mounted on the beach. And then on the left, we've got a drawing that was made, a pastel that was made during the totality by one of the French. So these are photos and records taken from accounts from archives in France. But what was interesting about that particular eclipse was that King Rama IV, born 1804, died 1868. Hey, the eclipse occurred in 1868. I wonder if there's a connection. King Rama IV was also interested in not just in observing the eclipse scientifically, but he was interested in using it as a political weapon. So the crocodile and the whale. What's that all about? A lovely title for a lecture, surely. Well, as we saw before, we've got Siam here, sandwiched between Burma, British, and the French. And both of these nations were vying to take over Siam and make it a colony of their country. So what King Rama IV decided he would do was he'd play them off one against the other. So he invited the French to send a scientific expedition to to Siam. The French had another expedition which went to India. But he decided he would also carry out observations from the same locations where the French scientists were, we saw on the previous slide. But he also invited the leading British politician of the day, who was at the time Lieutenant General Harry Ord, who became Sir Harry Ord very soon afterwards, who was in charge of the British area here, what was called the Strait Settlements, and was based in Singapore. So Harry had no interest in astronomy, no knowledge of astronomy, no experience in astronomy, but he was a politician, and he was a very astute politician. So he accepted the king's invitation, and he was treated like royalty. In fact, he ended up building a thing that looked like a royal palace, which is called the Istana, back in Singapore, and wasting a tremendous amount of taxpayers' money on that. And he had a very bad reputation in Singapore, leaving only his Istana as a lasting memorial. But what he did was he carried out observations of the eclipse, and all by naked eye, and he ended up publishing a booklet, which we can see a copy of the title page of here on the right. And he's got drawings of the eclipse, which of course are fascinating, but they have no scientific value. But Sir Harry ended up representing the British, The French were represented by their astronomers, and the location of the site was actually just here, which we've been to. And at the time of the eclipse, there were like 24 ships, warships, all anchored off here. About 2 of them from the French, about 2 of them from the British, and all the rest by the Navy of Siam. So the King's message was, hey, I discovered the observing site just the same as you fellas. So we've got the ability to carry out scientific mathematical astronomy in Siam. We've got the ability to carry out observations. We don't need you fellas here to teach us how to do astronomy. Besides, we've got a Navy and there's only 4 of your ships. We can sink you easily. Just bugger off and leave us alone, leave us to be Siam and forget about trying to take over. They all buggered off, excuse the pun. And Siam was able to survive. So Darunee, Lingling and I have written a paper about this, which is all about politics. There's not much astronomy in it, except the pretty pictures from Lord Harry Ord's book. But it's a wonderful, wonderful story. So you can see this is why sometimes when we're doing research on astronomy, we not only have to go to the site, we have to go to Singapore and go through the archives, and we end up producing a research paper that is very fascinating and is more than just about astronomy. This is why I love doing history of astronomy. I mentioned that there was another location, and that was this one here. And this was it was actually the observations of the same eclipse that 1688 was carried out up here by this man here, Oudemans, who was in charge of the geodetic survey of Indonesia, of Dutch East Indies at the time. So his job was to carry out observations, latitude, longitude observations throughout the whole of the Dutch East Indies. So you know, that was a large area. That was also the area here. And he carried out observations there, and he got support from the government and so on. But there was another total solar eclipse visible just a few years later in 1871, and that was visible from Java. So here's the capital, Jakarta, and here's his observing site here. And there were other observers located at these 3 sites here because they're along the eclipse path, which we can see here. And he carried out observations and published on that. So he was able to observe 2 total eclipses successfully and publish papers in German on both of those eclipses. And then soon after that, in 1875, we have another eclipse visible also from Siam. So the earlier eclipse was visible from here. This one's visible closer to the capital, which is here, which is Bangkok, was the capital in those days. And we've got another king, King Rama V, patronizing astronomy. And the reason he did this was because when he, as the son of King Rama IV, was observing the eclipse of 1868, he and his father and most of the contingent there all got malaria. They all survived. Just one person died, his dad. King Rama IV paid the ultimate price for his commitment to astronomy. He died from malaria. And King Rama V, hardly out of his teens, the new king of Thailand, of Siam as it was, interested in astronomy, supported a British expedition led by Sir Arthur Schuster from Manchester University, and they observed from near the capital. And in the capital itself, King Rama IV and all his royal family carried out observations because its totality was visible there. And one of the people in the audience, Visanu Yuachukiati, has carried out research on this, and he's published 2 different papers. One about the scientific observations carried out by Schuster, and we can see 2 of the photographs of the many photographs taken that he was able to locate at the RAS archives in England, and also part of the photographic telescope we can see on the left-hand side. So Visanu has carried out research and published 2 papers, both of them in that book there. So 2 chapters of that book. Excellent, excellent work. And of course, we've got now 3 kings, Rama 4, Rama 5, and of course, Marai, all supporting astronomy. But we have another king interested in astronomy, but not really following it at all. And he supported yet another expedition, which again was in Siam, but right on the border with British Malaysia in 1929. And this eclipse was of interest because although Einstein's theory of general relativity had pretty much been proved in terms of the refraction of starlight by earlier eclipses, there was still an interest in trying to carry out observations and confirm the earlier observations. So the king on this occasion invited both British and German expeditions to be based at Patani, which we can see here. And the former director of the National Astronomical Research Institute of Thailand, which I used to work for, Bunraksa Sunthontham, he has carried out research on this, and he and Visanu, and I have a paper in that book that I was just talking about. But as well as that, just across the border at Alor Star, which is in Malaysia, there was another British expedition. So the British ended up sending out 2 expeditions, or the one expedition split into 2 parts, and one stayed in Patani, the other went to Alor Star. And Noor, who's an amateur astronomer from Malaysia, and I have carried out research, and we've published a paper in that book that I was talking about the observations there. And meanwhile, there was also a German expedition at Patani. So we've got 2 expeditions at Patani and 1 here, but unfortunately they were mostly clouded out. So I've been looking at other expeditions, and there was one by the French at Pulau Condor Island. They were successful. So at the present time, we're carrying out research, a joint research project with a French colleague and a Vietnamese colleague. This is Vietnamese territory. We're researching that, and we'll be publishing a paper, probably in the 2nd volume of the Southeast Asian book, if that comes off, otherwise in the journal earlier than that. And then the other location where there was successful observation was in Dutch East Indies here at Takangong, up in the mountains. Those down on the coast were clouded out. Those in the mountains had a clear sky until the eclipse. So we've got a German expedition and an American expedition there. So we're researching those at the present time. Now I want to spend the rest of my time talking about ethnoastronomy, because this is where I think of all of the research projects, we can do the most exciting work, and we can make contributions that are going to be of the most important international contributions to astronomy. And that's because Southeast Asia, the areas that I'm talking about, offer special research potential. But the projects are very ambitious and require substantial manpower, woman power as well, if we're going to do that successfully. And one of the projects I haven't tried to launch, well, actually I did a few years ago, but it didn't work because we need a lot more support, is this what I call hill tribe astronomy. And we find that over a period of several hundred years, dating back from about 800 years ago to 1,500 years ago, we've got various tribal groups along the border here in southern China, migrating into the northern parts of Vietnam, this whole area of Laos, this whole area of Thailand, and basically this whole area of Myanmar, Burma, into areas of India up here, and even part of Bangladesh here, linked in there. So we've got what we call hill tribe people, who are not the traditional occupants of these areas at all, these countries, but quite different. So they're different ethnically, they're different religiously, they speak different languages, they have their own cultures, and they've preserved their own cultures. And some of them, like we see with these delightful young ladies down on the bottom right, they have really tapped into the tourism market. So these are actually Karen tribe people from this area up here, up near Chiang Mai. This is where I'm based, just up here. And we've now got anthropological, archaeological, genetic, that's important, and linguistic, that's important, evidence where we can locate the source areas of all of these groups before they migrated from South China into these areas of Southeast Asia. So we can date the source locations, we can date the actual migrations. Once they move into specific areas, we can look at what kind of local influences impacted upon their cultures and their astronomy. So were they invaded by Buddhist temples or Hindu temples and Hindu and Buddhist religion, for example? Or were they dominated by British colonial astronomy in Myanmar, or by French astronomy once they moved into northern Vietnam, for example? We can also have a look at the ecological links, given that there's a relationship between human ecology, a direct relationship between human ecology and traditional indigenous astronomical systems. So we would expect to find the astronomical systems varying if, for example, they migrated as hunter-gatherers, and then because they've got neighbours who are agriculturalists, they start to practice slash and burn agriculture. So their astronomical systems would evolve to accommodate this changing ecology. And if they then evolved from hunter-gatherer to slash and burn, and then from slash and burn to sedentary rice field cultivation, cultivating valleys and even terraces. And so again, are we going to find an evolution of the astronomical systems connected with that? These are the kinds of things actually that Darunee, Lingling and I and some of our collaborators are looking at in other parts of Southeast Asia, but they're the sorts of things that we can look at here as well. But we think that it would be fascinating to carry out a astronomical comparison of all of the different, as many as possible, of the different hill tribes that are scattered throughout these areas, and compare and contrast their present astronomical systems, take account of the timeline since they settled the area, the ecological and local influences, account for those and try and track down the ways in which their astronomical systems varied from the time of initial migration. That also means that the Chinese have to come to the party and carry out ethno-astronomical observations of the people in southern China who've remained there, and also take account of those kinds of variations too, and the impact of Chinese Chinese ideology. So does communism require a different kind of astronomy amongst hunter-gatherer or slash and burn people on the hill tribe borders from other parts of China? No one's looked at this sort of thing. This would be fascinating. This is a unique astronomical field laboratory, as I like to call it. And we can compare these different astronomical systems. We can compare them, we can contrast them, we can try and explain the differences between astronomical systems. We can try and explain the ways in which the astronomical systems of the different tribes and ethnic groups have evolved through time over the last 1,000 years. And we can also try and pin down how much time it takes for an astronomical system to change once a culture is changing and the astronomy is changing with it. Darunee, Lingling and I have researched this amongst the Maori, and we've shown that it takes about 300 years for an astronomical system to completely change from one major form to another as a result of a major change of environment. So are we going to be able to come up with similar kinds of dates? Darunee, Lingling and I have been looking at that in relation to Java, and we'll be working with Taufik Hidayat and colleagues there in terms of, can we track the amount of time required to change the ancestral astronomical system of Javanese people from the time rice cultivation was introduced till we've got an astronomical system that's found there today. So you can see it's possible, if we can tie down a number of these variables, it's possible to actually come up with some very interesting results. I just want to show you this slide to indicate the enormous diversity of these hill tribe people. So I've got here photographs of hill tribe people from the area near India right through to Vietnam, Laos, Cambodia, Thailand. So we've got Thailand people here. We've got people here from Vietnam. We've got people from India. We've got, I think that's Laos or Cambodia. Laos, Cambodia doesn't have any of these people. That's Laos. And here we've got some people from, again, from a different part of Vietnam. So look at the difference in the morphology of the people, and their languages are different. Their astronomies are different. Their cultures are different. Astronomy is part of culture. Their languages are different. Their clothing's different. Everything's different, including the astronomy. This is a unique opportunity. But what we need to do is set up a system where we've got a regional coordinator in each of these countries. We've got a team made up of anthropologists and astronomers, and also other people that we might need, say in terms of geology, changing environment and so on. We need to have a research collaborative team for every one of these areas. And the way to do this, of course, is to start with one case study and then try and do this. Unfortunately for old people like me who can't do fieldwork very easily anymore, it's too late for me, but it's not too late for the young ones. So this is a chance to do something that's going to be really, really exciting and world-shattering if we can get the kind of results that I am convinced we can get from this area. Okay, so that's one of the two ethnoastronomy projects. The other one is the one that I am working on in collaboration with my colleagues from the Philippines, and we've also got collaborators working in Andaman Islands, they're Indian colleagues because that's part of Indian territory now. So that's why I'm working with ethnoastronomy people in India. But I'm banned from going there because I'm a Westerner, so they can do the field work, which they've already done some of. And we've got a colleague who's now working on the one tribe that's left of these kinds of people down here in the very southern tip of Thailand. I'm up here, she's down there. But unfortunately, we've had COVID. We can't do any of the field work. So her research program's been designed and lined up, and we're just waiting for a time when it's safe to go in and do the field work. And it's now or never with that. It's now or never is our theme song from Elvis Presley. It's now or never. You know that song. You all know that song. Okay. All us geriatrics know that song. Wonderful. It's our theme song. Whenever we have a Southeast Asian Astronomy conference, and we've had 3 of them, we all sing the song. It's part of the ethos of the conference and of our working group. Okay, it's now or never. If we don't go in the case of these people from the southern, here they are. Let me just go back there. Go back first. If we don't go and do our field work amongst these people here, there won't be any of them left. All the old ones will have died. We will have lost the information. So we've got field work to do in these areas, and the Philippines people have started doing this, and there's a lot more to do, but exciting results coming already. And then throughout Malaysia, there's a whole lot of these different ethnic groups. That's why there's a big circle. This represents more than one ethnic group. These represent individual ethnic groups, but we'll see even those are simplistic in a minute. So we've got 2 colleagues in Malaysia are carrying out research, one of them doing this for her master's and supervised by an anthropologist from one of the universities who's sympathetic to astronomy. So we've got research going on here, will be going on here soon, is going on here, has been going on here, and there'll be lots more. And these are the Negrito people. And we find them in these areas, but we also used to find them here. There's lots of evidence of them from some of the research DARUNEE, LINGLING and I have been doing. And they used to be here. And they date to a time when actually the coast came around like this. So they used to be across this whole area here. But of course, it's all underwater now. We don't have any of their sites. We can't investigate them. But we've got groups of them surviving in these areas. And they settled this whole area between about 50,000 years ago from India, 50,000 to 35,000. The latest settlement took place about 35,000 years ago, this way here into the southern part of the Philippines, Mindanao. And so they would have been throughout this whole area 40,000 years ago. And we call them Negritos because they look very similar to some of the small stature tribes that we find in Africa. So the small stature, black curly hair, dark skin, sparse body hair. They are completely different to the present day people that we find occupying the rest of this area of Southeast Asia. And what we're hoping is that we are able to take out the later astronomical systems that were introduced by later people, by colonialism and by religion, and actually pin down some of the elements of the traditional astronomical systems of these people by studying some areas of them where they've been relatively isolated. There hasn't been a lot of interbreeding between other ethnic groups, later ethnic groups. So that's part of the objective. So here we can see the people, the Mani from southern Thailand. So here at the top right, we can see a typical man. Here's a typical Westerner. So these people, they're about 1.5 meters tall on average. They're significantly shorter than the average Western man. And we can see here a whole group of them. So dark skin, frizzy hair, short stature. Here's a map showing the location of the border between Malaysia here, or Malaya as it used to be called, and Thailand, Siam, because Thailand was only named in 1939. So here we've got, in 1920, we've got groups of them living in all of these areas. Traces of them still here. By 1980, they're only restricted to just 2 areas down near the border. We think today there are probably around 300 of them, still in 2 small areas, and one of them is actually near the village that the researcher who did a PhD in astrophysics up in Chiang Mai, she's now located here teaching undergrad astronomy at one of the universities. So she's waiting for a chance to get into this area here and carry out research. She's located here. So we're hoping that there's still going to be a few, maybe only half a dozen, even less, elderly Indigenous people who've still got astronomical knowledge. Or maybe it's just too late, we don't know. So this is critical. It's now or never with them. It may be too late. If we go to the next slide, these are people that Nur al-Jafar, the lady who's doing the master's degree, has been researching. So here are slides, photographs from some of the groups that she's researched, and she's been writing, but mostly in Bahasa Melayu language. We've still got to get more material from her in English, but the book that I talked about, the Southeast Asian one, has got a couple of chapters by her and her supervisor that talk about some of this work. And here's the Negritos from the Philippines. So remember the map? All of the dots here show where I've been able to document the existence of Negritos, either at the present time or from 1950, 1950 or earlier. But as I said, I haven't included, because I only found out later, there needs to be another dot here. And then there are people living in this area here who range from complete Negritos to people who've only got very small Negrito blood. And you can see a gradation as you head inland into the central mountains that's described by the anthropologists when they talk about their field work in this whole area here. So this is an area that I'll come back to in a minute. Okay, so look at all the dots. That's where we know there are individual ethnic groups, tribal groups. And many of these have actually been researched, not all of these, but some of these, this one has, that one has, a couple of these, one of these has, that one definitely has. But of these, only a couple have been researched in terms of astronomy and even anthropology. So compare the detail. This is a map that I assembled on the basis of going through all the literature, compare that with this. So you can see that was my starting point on the Philippines map, and now we've got pretty much the truth. The interesting thing, and here we've got some examples from 2 of the different areas. So we've got the different names. One of the things that I think we'll find when we look at the evidence, looking back through the Spanish records for the last 400 years, Spanish colony, the different Jesuit missionaries and other Spanish officials, they've been in these areas and recording information about these people for hundreds of years, since the 1680s. So I think we'll find in the case of the people up here, I think we'll find that originally there were maybe 3 or 4 different groups, one up here with different names. And now they're all just linked with the same name and regarded as the same anthropological group. These ones are even 2 different groups that we'll see in a minute. What's interesting, oh, sorry, that wasn't meant to happen, nor was that. Jared, how much time have I got? 5 minutes?
If you don't mind, Wayne, so we can ask you some questions, please.
Yeah, okay. So
Thank
we'll
you.
just finish this off. What we've got here is an indication of the different groups. And what we want to do now is see how we can interpret those. So when we look at the Negritos and we compare their genetic signatures from Philippines over here, compare them with the Malaysians and Andaman Islands, we can see the colored schemes are completely different. So we're looking at 3 totally different ethnic populations, ancestral ethnic populations. We also see that if we have a look at the Negritos, so we can see them represented here, for example, and here, they're completely different to the people up here. If you look at the color schemes of these different pie charts, and we can see that these ones here are rather similar. We can see that this one is quite different. This is also a Negrito. We can see Negrito here, different to all these others. So that's looking at Y chromosomes. If we go and look at mitochondrial DNA, we've got similar information. So anything with this cerise color shows that there's some of this Negrito blood. Where we've got none of it at all, that shows totally different groups. Where we've got a mix, it shows this genetic mixing. I talked about the 3-phase model being simplistic, and that's as a result of this study here, which we can see on the right, where this group of people, Arena and L, in 2021. So last year, they published a paper where they've carried out the most definitive study ever of blood types of mitochondrial DNA for 1,028 different people from all of these different locations throughout the Philippines, including Negritos from here, up here, 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 and in here, and here. And when they do a principal components analysis of that, they find that a lot of the different groups link together, overlap, which shows that there's been a lot of interbreeding between the Negritos and later ethnic groups. So if we want to study the different astronomical systems, we have to find the isolated ones where there's no change, where they're producing, or they've got a basically pure genetic form. So we've got the sea gypsies here, which are from this area here. We've got these people here, which are the ones I talked about up here that's different. We've got some Negritos here. We've got groups here in this island. These 2 of these 3 groups here are genetically pure. 2 of them are mixed. This is a Negrito. So I've got some evidence of that. And one of the fascinating things is that the people from here actually came directly from this area, from Taiwan. And they've got this one here, Kankane people, has got the identical genetic signature to these 2 ethnic groups. in Taiwan. So their astronomical systems, we want to compare and contrast them. We know what time these arrived in the Philippines. We know what the astronomical systems are there. Let's compare and contrast them, and we can then explain the differences. So we've got wonderful field laboratories. Mindanao is another example where we thought we just had the Negritos up here. And then we had later on, we had a group of Austronesians. Now what do we find? We've got Denisovans even earlier, then the Negritos coming in 37,000 years ago. We've got Manabo ancestry represented by this.
That's very muscular. Thank you for saying that.
And then we've got Sama ancestry, which is later, and we've got about the same time. And then we've got Papuan influx coming later again, then Muslim, the ideology, and then Spanish, British, and the US colonialism. So we've got a whole series of different astronomical systems superimposing themselves one upon the other. And what we want to do in the Philippines, in Mindanao, is actually carry out a series of additional observations and studies that beyond what we've already done to try and see if we can pin down some of the different astronomical systems of these people and how they've changed. So this is where we are at the present day. We've made remarkable progress in the last decade with lots of new research taking place. We've got lots of research papers. We've got this book, and we've also got chapters about Indonesia and about the Malay and about Thailand in that second Springer book. We've had 3 Southeast Asian conferences. We're hoping for that next one next year that I mentioned. So we've got endless national, regional and international opportunities to carry out research projects in archaeoastronomy, ethnoastronomy, ancient astronomy. You can see the whole lot there. There's areas that I've started doing research with collaborators I haven't even talked about, such as meteorites and tektites. So this diagram on the right-hand side there with all the red dots shows tektites scattered throughout Southeast Asia and also into Australia. So that's research area that we're working on at the present time. And I'm also carrying out research with a collaborator who's now in America on the meteorites of the Philippines. And we can see this map at the top there shows the location of the 5 gazetted meteorites. There's another one that's landed that hasn't been documented fully yet. And one of these, is by far the largest, the Bondok 1956. It's a very, very large meteorite, and it's also a very, very unusual type, mesosiderite, very rare type. It's in America, so we're trying to do research on that before, or while we still have a chance. So there's all sorts of areas like that, and like Jesuit astronomy that I alluded to, where we can do more research. We need lots more collaborators. There's lots more masters and PhD projects there for those who are interested academically. So lots of opportunities, and we invite any of you who are interested to join us. And also, if the Bandung conference comes off, the 2 conferences, the one about 100 years of the observatory, and also our 4th Southeast Asian conference, if that comes off in October 2023 in Bandung, Indonesia, we invite you to join us there. So thank you for listening. I hope you've found this an interesting presentation. Thank you.
Okay, if you'd like to unshare your screen, Wayne, and well, I for one have absolutely been amazed by that. I'll just go back onto gallery view, and I'm confident you're going to have a host of questions, and I've already planned a Christmas present for myself.
What, you're going to enroll for a PhD on one of these topics?
Anyway, Gerard, I'll let you do the official.
Wayne, that was incredible. Such a wide range of research you've been doing from certain aspects of the region. It's fascinating. You even covered something that I'm interested in, of course, is Victorian astronomy and the influence of the Jesuits, which was far and wide, really. And of course, they are associated with solar astronomy and its observation.
Dannyhurst, yeah.
I've got one question online, which I must let you Paul Fuller said, brilliant research, Wayne. I would never have thought of looking at the history of astronomy in the way you have. His question is, do you know why the Jesuits were so interested in astronomy and concentrated much effort in conducting astronomical research in Southeast Asia rather than anywhere else? Thank you, is his message.
Well, of course, they weren't just interested in carrying out scientific research in Southeast Asia. They were interested in doing this worldwide. And if you read Eudias's books, and he's written a couple now about Jesuit science, not just astronomy. So UDIAS, the first book was about 2003, something like that. And he's more recently, I think in the last few years, he's published a second book. He's gone and actually looked at this. Part of the whole philosophy when the Society of Jesus was set up was that, okay, it was a specialist area of Roman Catholic religion, but that they should study the religion in the context of science and technology. That was part of the philosophy. So right from the time when people were being trained in Jesuit seminaries, they were having to learn mathematics, science, and astronomy. And they were trained specifically in astronomy. And one of the things when they had to do when they went out for the first time into areas like, and of course, not just Southeast Asia, of course, China. Everyone knows about the Chinese and all the work they did, the Jesuits did there. Hardly anyone knew about the stuff in Southeast Asia. This is why I found it so fascinating when I discovered about this. So the first thing they've got to do is they've got to start carrying out scientific observation. They need to be able to produce a latitude and longitude. So doing your latitude is very easy. Just look at the star that's up at the zenith. You've got latitude straight away. Longitude's more difficult. So you can observe eclipses where you can compare the times that Cassini had documented for forthcoming eclipses, when they were going to be occurring, starting first and last contacts. At Paris Observatory, you can observe those from anywhere in the world where the eclipse is visible, so that's half the world, and you can compare and contrast the times. That will give you time equals longitude. Okay, so that was their philosophy, and that of course then meant that the Jesuits could then put dots on maps and locate correctly places. So I found it very fascinating to actually look at this Jesuit thing, because as I said, I'm a Buddhist now, but before I became a Buddhist, I actually did research on Riverview Observatory in Sydney, and I published a paper on that back in 1985. I had a visiting fellowship at Mount Stromlo Observatory for 4 months, and I spent part of the time researching that topic, and I wrote a paper about it. And looking at the linkages between the Jesuit research astronomy there and Boschke Observatory. And the two Boschke fellows, they weren't Jesuits, and it wasn't a Roman Catholic observatory, but they were doing the kind of research that the Jesuits felt, with the limited instrumentation and personnel that they had in Sydney, that they could do, and that would make a worthwhile contribution. So they actually set up astro cameras, which were donated by Boschke Observatory, and they carried out photographic studies, mostly of binary stars, but they also did photographic surveys and discovered new variable stars. That was their interest, variable stars. So you can go back, you know, to the 1600s, and you can look at the Jesuits here in Thailand. You can look at them in China. King Narai, I didn't tell you the outcome of that. There was a coup, because some of the people in the royal family and other nobility weren't happy with the fact that he was espousing scientific astronomy and supporting these Jesuits from France and building big observatories modeled on Paris Observatory. So they staged a coup, and they poisoned him, and they bludgeoned to death all of his main supporters, including the heirs. And then the relative who organized the coup went and banished all Westerners, almost all Westerners, from Siam. So that was the end of astronomy in 1688. It only ran from 1681 to 1688, but a tremendous amount was achieved in that time. And that was really sad, because it was only when the eclipse came in 1868 that we get Westerners coming into Siam again and carrying out scientific astronomy.
I don't want
And those
to,
Jesuits,
I
they
don't
went
want to
to
be
India.
rude and interrupt you, but it's just that we're approaching 2 o'clock here in BST. I just, if I may, there's a message from Laura Carroll, a very informative and comprehensive talk. Thank you so much. I think that's reflected by everybody. Could I ask if there was one more question from anybody who's still with us? If they want to ask their own question? Put your hand up, please, if you want to. I've got one question for you, if I may. You mentioned about the temples, the ones that had an astronomical interest, many of them were actually covered by jungle and have only really been discovered in, well, modern times. Is that right?
With the Hindu temples throughout, Indonesia and Thailand, Southeast Asia, yes, certainly that's the case with some of them. With the Buddhist temples, of course, that's the prevailing religion, so we don't have that kind of a problem. I must say I haven't done any research on temples myself. The one project I'd like to do is that one in Bali. I think that's fascinating. And when I've talked with colleagues in India who've studied temple architecture and astronomy, and there are a couple of them who've written about this, and both close friends of mine, they know nothing about any temple like the Bali temples with the multi-stories anywhere in India. So we're wondering whether in fact that temple design originated in Bali. I don't know. I'm just getting too old to do these sorts of projects. I've got to find the young ones and get them involved in this. So what I'm trying to do is act as a catalyst, show all of the different exciting things that we can do and get other people working on these. And I'm happy then to provide guidance if need be.
Well, I really am upset that I've got to bring the webinar to a conclusion. I just want to really give, I suppose, the official vote of thanks and to thank you very much indeed. It was excellent. It really was. My introduction was almost as long as your own presentation, but that's a reflection really on all the work and of course your wife and your research assistants have done over a really large, wide range of subjects. And I wish you well with the continuation of your research. And I do in many ways look forward to the conferences that you've mentioned. So if everyone would like to, in their own physical way or electronic way, please thank Wayne for his fantastic presentation today. Thank you. Thank you so much.
Thank you very much. I'm happy to answer any questions or comments on email.
Yeah, sure.
And of course, this is about Southeast Asia. I do a lot of research on Australia and New Zealand, amateur astronomy and radio astronomy. So if people are interested in those areas as well, I'm very happy to talk with you about British colonial astronomy.
Yes, we will certainly pass on any additional questions that we get, especially when the presentation goes online as well. We'll forward them on to you.
Yes, I'll just say that once we finish, I'll stop the recording and then it'll take half an hour to convert itself. I'll put it on the website, but I will ask Gerard if Graham could bill it to all SHA members, because I think it's absolutely fascinating talk.
Yeah.
And may lead to some more Christmas sales for you, Wayne. You never know.
I don't get any funding from the books. I don't get any royalties. Don't worry.
We've all been there. We understand that.
Yeah.
Again, Wayne, on behalf of the SHA Council and the wider memberships, thank you so much again. And I hope we can call upon you perhaps next year to come back and give an additional talk. Thank you.
Yeah. Okay.
Okay, thank you very much. It's been a delight to be here. Okay.
And
bye-bye.
Just to thank everybody again for being with us.
And goodbye
today,
to all of those colleagues.
I hope to see you in face-to-face in October for those of you coming to Birmingham. So thank you very much. Bye-bye now.